Hello viewer, today we will discuss about the frequency used in the satellite communication, its band designation. The frequency used are divided into several bands. We will talk about the band designation and the advantages and disadvantages of those bands and allocation of the bands in various uses. The frequency used in satellite communication is falling under the microwave range. We already come across it. And this microwave range as such is starting from 300 megahertz to 300 gigahertz. It allows efficient generation of signal power in this range, and beyond this, there will be several difficulties in generating higher power. And this energy is radiated into space. Energy may be focused into a very fine stream of electromagnetic wave is called the beam, and that beam shaping and directivity of the beam is usually done by using suitable antenna system, and efficient reception over a specified area is possible. Properties vary according to the frequency used. Propagation effects is a factor. It includes diffraction, noise, and fading, and the size of the antenna also is a factor. Once again, I like to mention that 0.3 gigahertz to 300 gigahertz is the microwave frequency range. And we know that this microwave power, it propagates in the space and through the atmosphere following the line of sight principle. So line of sight propagation is the fundamental issue in a space and atmosphere. This frequency range is very much prone to a power loss by the blockage of denser media like these hills, buildings, rain, etc. Wide bandwidth compared to lower frequency bands is achievable because of the higher frequency of the carrier. And in this frequency range, as we go to higher and higher value, the antenna will be smaller and smaller, because most of the antenna are the resonant antenna. So it depends upon the wavelength, and as the antenna size is very small and very much limited, so the directionality is easily achievable. Actually, as the frequency is increased, the power generation becomes difficult. So the power generation is reduced at higher frequency. 1 gigahertz to 170 gigahertz spectrum divided into several bands with the later designation. This is basically a universally accepted band allocations and band designations, like usually used bands are L band, S band, C band, X band, KU band, K band, and Ka band. L band, the frequency range is 1 to 2 gigahertz, and that is used for MSS, mobile satellite service. S band, it is starting at 2 gigahertz and ending at 4 gigahertz. So it is 2 to 4 gigahertz, used for MSS, mobile service once again, is the higher frequency, and for deep space research, which is usually used by NASA. C band is 4 to 8 gigahertz, used for FSS, fixed satellite service. X band, it is starting at 8 gigahertz and ending up to 12.5 gigahertz, used for FSS. Again, is the fixed satellite service, and in terrestrial imaging, which is usually used by the militaries and also used by the meteorological satellites. KU band 12.5 to 18 gigahertz is the band, frequency band, used for both FSS and BSS, fixed satellite service and broadcast satellite service. Direct broadcast satellite is DBS, is using the higher part of the KU band from 14 gigahertz to 18 gigahertz. K band, it is quite high frequency, 18 to 26.5 gigahertz, used by FSS, again, fixed satellite service, and BSS, broadcast satellite service. Ka band, it is from 26.5 to 40 gigahertz, used by fixed satellite service. So these are the several bands: LSCX, KU, K band, Ka band are the bands. Satellite communication started with C band, 4 to 8 gigahertz. It is very popular band, and nowadays that band is very much loaded. That's why KU band is becoming very popular nowadays. Advantages of C band 6.4 gigahertz. 6 gigahertz is the uplink frequency and 4 gigahertz is the downlink frequency. What are the advantages? In this band, there is no absorption by rain. That is the very basic advantage. Less propagation problem, which is less than that of 10 gigahertz at an elevation angle of 5 degrees. This propagation problem is very much related with the residual atmospheric molecules and severe effect is there of the ionized particles there. So that problem is less in C band 6.4 gigahertz. No change of polarization when wave passes through ionosphere. As we know, during propagation, the wave has to pass through the ionosphere, which is ionized media, and at very high density of the ions, it acts as a metal, so it is very difficult to propagate the EM wave through that. Easily available as it is used for terrestrial relay. So this is very popular band, 6.4 gigahertz. Common uplink and downlink frequency of these popular bands. This L band, it is larger wavelength. So the frequency starts from 0.95 to 1.45 gigahertz. This is used for GPS at 1.57542 gigahertz. C band 3.7 to 4.2 is the lower part of the C band, and 5.925 to 6.425 gigahertz is the upper part. The upper part is used for uplinking, and this lower frequency band, lower frequency part of C band is used for downlinking. KU band, that is again divided into two halves, 11.7 to 12.2 gigahertz. That is usually used for the downlink frequency, and 14 to 14.5 gigahertz for the uplink purposes. So the C band, KU band, and L band are very much popular bands. And out of these three, C band is the most popular and it is almost used up band. Ka band, it is 18.3 to 18.8. Have two lower span of the frequency, 18.3 to 18.8, again 19.7 to 20.2 gigahertz. These two parts are for the downlinking, and 30 gigahertz is for the uplinking. So Ka band, the lower part is divided into two, and these two are being used for the downlinking, and 30 gigahertz, the higher part, is for the uplinking. V band, 40 to 75 gigahertz is much higher frequency, very small wavelength. 60 gigahertz allocated for unlicensed Wi-Fi use. 70, 80, and 90 gigahertz for other wireless applications. L-band is the comparatively longer wavelength. Lambda is 30 centimeter. Frequency is 0.95 to 1.45 gigahertz. These are usually used for amateur radio communication and GPS devices. Features: mostly this patch antenna used for GPS receivers, low rain fade, low atmospheric attenuation during the travel in the long pathways. Low power is available in this range. Small receiver configurations. As it is related with the smaller power, so receiver also becomes small, and most of the layout and components are smaller. Frequencies 3.7 to 6.4 to 5 gigahertz, lambda is equal to 5 centimeter. This is used in TV reception, mostly in the motels. IEEE 802.11 is for the Wi-Fi application. This band is used for Wi-Fi application, IEEE 802, and very small aperture terminal, that is the VSAT application. So this is very much popular, is this part of the C-band. Features: large dish antenna needed, 3-meter diameter, low rain fade, low atmospheric attenuation, long paths, low power terrestrial microwave interferences. Frequencies 12 to 18 gigahertz, lambda 2 centimeter. The uses of this frequency band is the remote TV broadcasting, satellite communication, VSAT applications. Features: rain, snow, ice on this this band has the susceptibility to rain, snow, ice. Small antenna size because of the lower wavelength. High antenna gain and high power are allowed. Ka band 18 to 40 gigahertz, lambda is almost 1 centimeter. Uses high resolution ladder. This is used for the high resolution ladder application. Communication systems, deep space communication, mostly used by the space research. The other features are obstacle interference exists there. building, vegetation, etc. So obstacle interference is very prominent, dominating, and atmospheric absorption also very much dominating point. V-band frequencies 40 to 75 gigahertz, lambda 5 millimeter. The uses of this band is military wave radar research application, very expensive, high capacity millimeter wave communications, point to point fixed wireless system, Wi-Fi application. The specific feature of this frequency band is very prone to rain fade, obstacle block path, atmospheric absorption, and expensive equipment. So as we go to higher and higher frequency, this loss due to obstacles, loss due to rain, and interaction with the atmospheric particle are very much severe, and generation of the power in this frequency range, higher frequency range, is also becoming very expensive. Thank you all.